lesson on first differences, which will connect to slope and to everything we've done with graphs so far, and you'll see how that's going to make our life. First differences are actually a very easy concept that make life easier. So go ahead and write down the reason we're learning first differences is it allows us to figure out if a relationship is linear. And remember, linear means a straight line relationship, okay? Linear straight line based on a table of values. When I say first differences, Charlie wants to play. See, he's got his baby here and he wants to play. He's not into doing any math at all right now. But too bad, Charlie. So when we say first differences, we mean differences between the y values in a table. So, the y value is the dependent value. And if we look at this table of values, here's a list of x's, here's a list of y's, and we're supposed to calculate the first differences. That's all we're asked to do at this point. And when I say difference, you should always think when you see the word, difference, that means subtract, right? So when I'm doing a first difference, I'm looking at consecutive, and when I say the word consecutive, it means one after the other. And I would the way you do a first difference is you look at those and you go minus 1, minus minus 2, right? So the first difference would be minus 1 minus minus 2 equals minus 1 plus 2, or 1. And that would be the first difference. Let's see if it's the same for this one. Between those two, you're going 0 minus minus 1 equals 1, right? So it's the lower one, subtract the higher one. Here, the first differences between those two is 1 minus 0, which is 1. So what we've done here then is not only have we calculated the first differences for our table of values, we've also seen that they're the same, and that actually tells us something. Okay? So again, what you do is you take the lower value, you subtract the upper value, and that's what this is. The lower value, subtract the upper value for every time. So if you're asked to calculate first differences, you take every piece of data in the table, and that's what you do. So what does it tell us? Well, if x goes up by the same value every time, okay, so x, see, you'll notice that this table of values that x goes 0, 1, 2, 3, 4, or so 0, 1, 2, 3. So it's always going up by 1. Okay, so if the x value goes up by the same, it could be 1 or it could go up by 2s. It could be 0, 2, 4, 6, 8. But as long as it's going up by the same number every time, and if the first differences are constant, right? If that's constant, that means that my relationship is linear. And if I graph it, I'd get a straight line. So linear means if you plotted the data, you'd get a straight line. And that's what first differences tells us. It also tells us something else if in a special case, but we'll get to that. Okay, so our example then, use the first differences to determine if the following relationship is linear or nonlinear. So linear means first differences are constant. Nonlinear means that they don't go up by a constant number. So just to go back to the skill then of finding first differences, here you take these two pieces of data, you go minus 0.5, take away minus 1, and that would be plus 0.5, because minus 0.5, two negatives is a positive, so it would be 0.5. Do the same thing here. 1, take away negative 0.5 is 1 plus 0.5, so it's going to be 1.5. All right away, not constant. Let's just do another one. We can already say that it's not linear, but let's go ahead and do the last one. 3.5 take away 1 is 2.5. So, the first differences are not constant, therefore it's a nonlinear relationship. And that's pretty much given away because I have the graph right here, by the way, and you can see that it's not a completely straight line. first if are not constant. Now, I suppose the first check I should have done was to look here anyway and make sure it goes up by the same number. It goes up by ones. And again, as long as it's a constant jump between the x's, then you can do this. So I really should have done that before I actually went ahead and calculated the first differences. But anyway, that's the end. Nonlinear. Next. Okay, confirm that the following relationship is linear. Okay, well, the way you would do that, if that's the question, the method is first differences. And when it says, I just thought of that, when you look at this and say the following relationship, this data is the relationship, and this relationship can be represented using a line, it can be represented using an equation, or a table of values. We're looking at it as a table of values, but we could turn this into an equation, and we'll learn that, right? Look at this, determine the equation of the line. We could graph it, and you would see this relationship in different ways. So any set of data kind of has different ways you can represent it. Anyways, first differences is 6 minus 4, so 2. So I'm going to assume it's going to be the same here, and you can see it already. You don't really need to write that down, do you? 8 minus 6 is 2, and here, 10 minus 8 is 2. So that's my confirmation that it's linear, so check. Okay? You don't really have to do any more than that. Now, here's something that is helpful. We use the term m to say, we call that slope, which again is rise over run, however you want to put it on a graph. Well, we can look at the table of values and find the slope. If x increases by 1 each time in the table, okay, in this case it does, so we can do this. If it didn't go up by 1s, I couldn't do this. But because it goes up by 1 every time, the slope is equal to the first differences. So I don't have to do any math. There would be a way to do this with math. I could do x2, this is basically just a set of data on the graph, but we can just say slope equals m equals 2. Oopsie, 2. It's my first differences. Because, and I can only do that because 0, 1, 2, 3. So if it went 0, 2, 4, 6, I couldn't do that. But because it's going up by 1 every time, slope is equal to first differences. Okay, what's the y-intercept? Well, y-intercept has the symbol b. Determine the y-intercept, which has the symbol b, and it's the y value where x equals 0. So this one we can read it off the graph. When x equals, or the table of values, when x equals 0, y equals 4. So b equals 4. And now write the equation of the line. And so you say just y, and you sub in, instead of writing m, you write 2. You keep the x. Instead of writing b, you write 4. So what we've done here is we've got two methods of expressing this relationship. Here's a data table, a table of values. That's one way I can demonstrate the relationship. Another way is this equation. Okay? And a third way would be a graph itself, but this one doesn't ask us to graph it. Okay, now here's a weird question. I think I took this out of your textbook, but this is a typical EQAO type question. Use first differences to determine if the relationship is linear or nonlinear. And the relationship is number of circles, so in this case it's 1, in this case it's 2. So this is supposed to line up, not that great, but this is supposed to line up there. This one's supposed to line up here. This one's supposed to line up here. And then, we don't have a picture for 4. But we might be able to figure out 4 without even drawing it. But use first differences to determine if it's linear. Well, first we have to fill out the data table. So number of intersection points means like here, it's easier to see on this one, here and here. Okay, where the two circles overlap. So when there's one circle, there's 0 intersection points. Okay. Where there's 2 circles, it's 1, 2 intersection points. This is an interesting question. Where there's 3 circles, you got 1, 2, 3, 4 intersection points. Now you could probably guess if you wanted to follow the pattern 0, 2, 4, 6, but let's just verify that. So if we drew all our circles, let me exaggerate it a bit so you can see. And I didn't draw very good circles, but hopefully you can see 1, 2, 3, 4, 5, 6 intersection points. And just to be clear, get the idea of independent variable and dependent variable, right? The number of circles is independent. The number of intersection points is completely dependent on how many circles there are. Okay, so use first difference to determine if it's linear or nonlinear. Well, first difference here, 2 minus 0 is 2. First difference here, 4 minus 6 is 2. This one, 6 minus 4 is 2. So definitely linear, okay? If linear, write an equation for the line it represents. We need to come up with the equation. Well, the equation, we need y equals mx plus b, right? So first the slope. The slope is the first difference if x goes up by 1. X goes up by 1 every time, right? 1, 2, 3, 4. So m is going to be my first differences. Because okay, now the y-intercept, how do you find that? Well, the y-intercept, again, is the y value where x equals 0. Well, that's not on my data point. This is my x. I only go to 1. So I need to figure out where the number of intersection points would be. Now, from a practical point of view, by the way, 0 circles, you would say, well, that would be 0 intersection points. However, in a question where you're looking at, this is a linear relationship, we've got to pretend you could have 0 circles and what would be the number. And the way that you do that, is, you almost, I didn't put much room on my table, but it's like I could take my table of values and just keep going. So imagine I had, I'll just draw it right here, right? There's my x, there's my y. So that's supposed to be a y. So say I had my 1 and 0 here, 2 and 2 here. So I just rewrote these 2 sets of data points. Now if I went back up 1, so I made this 0, you just follow the relationship up the y's. So you subtract 2, right? So to get from 6 to 4, you subtract 2, 4 to 2, you subtract 2, 2 to 0, you subtract 2 again, and you get minus 2, right? And that follows the relationship, minus 2 plus 2 plus 2, right? So that means that b equals minus 2. Okay, so again, the strategy for doing that, I might type that out for you just to make sure you're clear, is to extend your table of values. Whoa, whoa. I don't know what I did there. Maybe I should find undo. Edit, undo. That was not good. Edit, undo. Okay, anyway, so to find, I'll put it down in the corner where you can see it. To find b, extend table of values. I'll move that over so it's neater. Okay, so to find b, you just extend the table of values. You extend it backwards in this case. Okay, So the last part of this question is, what if you go beyond the table of values? And we want to find the number of intersection points where there are 7 circles. Well, that means, the number of circles is really our x value, right? So x then equals 7. I just thought of something. We didn't finish our equation. Got thrown off by the the rotating screen. So we haven't actually found the equation. But the equation, just the general form, of course, is y equals mx plus b, right? And you keep the y and you keep the x in the equation, but you put in the values for m and b. So that means y equals 2x minus 2. Okay, and that's my equation. So again, when you write the equation for a line, there has to be just y in it, and there has to be just x in it, and the rest has to be numbers. When you find out the value for m, you put it in, and the value for b, and you put it in. And see how it's minus 2? And so instead of plus b, you go minus b. Okay? Now, the next question says, solve for the number of intersection points, and the number of intersection points is the y, right? So solve for y. Basically, it's saying solve for y where x equals 7. Just to, this is my x, my independent variable. Here's my dependent variable. So all I do is sub the x equals 7 into my equation. So my equation is y equals 2x minus 2. And so I say y then equals 2, and I'm saying x equals 7 minus 2 equals 14 minus 2 equals 12. And so what this means, and you could draw it to verify it, but it's saying solve for the number of intersection points. So if I had 7 circles in a row, how many intersection points would there be? And you can go ahead and do that right here if you want to. You could go ahead and draw 7 circles and count. That would be another way of doing it. But the great thing about math is there's always easier ways. And that's what we've done here. We've used the equation, the relationship. So that's the end of this lesson. That was a long one, and but that's it for today. So we'll do some questions related to that tomorrow in class. And remember to make note if you have any questions, if you're not sure, and we can talk about it in class.